What's up, math scholars? It's Tuesday. Everybody's really happy to be here. Big smiles. We are learning about logarithms today. Look, I've got this little cute little bird with a log, because that's what I think of when I think of logs. Grabbed that clip art from the internet. Your book didn't have that fun of a clip art. So yeah, it's a brand new, kind of confusing topic. So please ask questions today. I have a very shy class here, but I encourage them to ask questions. I'll pause the video if you don't want your question on the video, so don't be shy. Who's excited? Logarithms, yeah, woo! Yeah, logarithms. And there's a logarithm button I'll show you today too. Yay. All right, we're gonna full screen this and go to the next slide. How many of you guys have played that super fun dice game, left, right, center? Maybe you played it over break with your family. You get around a big table, you roll the dice, put some quarters in the center, maybe even dollars, and then the winner gets to keep all the money, right? Isn't that fun? Yeah, so when I do logarithms, I think to myself, left, right, center. And that's just one way I'm going to teach it. If that confuses you, one thing you can always remember, and this might be something to jot down, the little guy is the base. Jot that down. The little guy is the base. I'll probably say both of those phrases a lot today. Left, right, center, and the little guy is the base. Alrighty, so we are going to do a little exercise where I show you something that's written exponentially, and then I'm going to rewrite that same phrase, that same concept, logarithmically, so you can kind of see. You will be expected to go back and forth easily, okay? So let's just think of something that is a true statement exponentially. How about 5 squared equals 25? Everybody agree with me that that is mathematically true. 5 squared does equal 25. So that is written exponentially. 5 is the base, 2 is the exponent, and 25 is the solution. Now, to write that same concept logarithmically, here's what you're going to do. You're going to write the word log, you're going to leave some space, and you're going to write an equal sign. Then you're going to say in your brain two things. First, you're going to say left, right, center. And secondly, you're going to say the little guy is the base. The little guy is the base. So here's what left, right, center, and how it kind of works. It's almost like a crisscross action, and this is what makes it confusing. The 5 is the little guy because he's the base. He goes on the left. This is what I'm calling the left position. The 2 is the exponent, so he's going to go over on this side on the right. So you already see my crisscross action happening. And then the 25 is the answer. He's going to go in the center. So I'm calling this the left. I should write on it. People watching the video can't see me write. I'm calling this the left. I'm calling this the right, and I'm calling this the center. And that's how you have the left, right, center action. 5 to the second power equals 25. Do you see it? I know it's confusing, so ask questions. 5 to the second power is 25. The little guy was the base, and the 5 was the base up here, and so he becomes the little guy down here. Isn't that weird? Very strange. It's a new concept. All right, we're going to try several more examples so you get more comfortable with this. Let me think of another true statement. What about 7 squared equals 49? That's a true statement. Right now it's written exponentially. 7's the base, 2's the exponent, 49's the answer. Let's try to write it logarithmically. So we write our log and our equal sign, leaving us some space where we're going to insert the numbers. So I say to myself, left, right, center. The little guy is the base. So the 7 becomes your little guy. He's the base. He goes kind of where I call the left position. The 2 goes on the right, and the 49 goes in the center. So 7 squared equals 49. Do you see it? Thumbs up if you're getting it. All right, we'll try one backwards. I'm going to write something logarithmically, and you're going to tell me what it looks like exponentially. Okay? Okay. All right, so this is written logarithmically. I would say it to you guys. Log base 10 of 100 equals 2. Yeah? Oh, sure. Yep. So log base 10 of 100 equals 2. How would we write it exponentially? Anybody know? Kara?
100. No. 10 to the power 2.
Perfect. So she can say to herself, left, right, center. The guy that appears furthest to the left, to the right, 10 squared equals 100. So it's crisscross action. 10 squared is 100. You see it? The little guy is the base, so 10's your base. Let's try another one. Just try this over and over and over till we all get it. All right, so I would read this to you guys. Log base 2 of 8 equals 3. Log base 2 of 8 equals 3. What would it look like written in exponential form? David. Colin. Wrong news popped out. 2 to the third equals 8. Perfect. Everybody see it? All right, moving along. We kind of already did part A. It was 2 to the third equals 8. 2 to the third equals 8. Let's try part B. What would this look like in exponential form? Tanner.
4 to the 0 power equals 4.
Good. 4 to the 0 power equals 1, and that's kind of a concept to commit to your memory. Anything to the 0 power does equal 1. You'll see that popping up a lot and a little bit later today as well. Any number to the 0 power equals 1. All right, who wants to write part C exponentially for me? Tell me what it would look like in exponential form. How about Grace? Good job. 12 to the first equals 12, and any number to the first power is the same number right back at you. Ooh, this is where it starts getting weird. We have a fraction this time. What would this look like in exponential form? How about Hunter?
1/4 to the negative.
I'm going to put it in parentheses, just make it look nicer. Okay. Good job. 1/4 to the negative 1 power equals 4. It's weird when fractions get involved. It's a little more challenging. All right, we're going to write these logarithmically, and I'll give a ticket away for somebody who can come up and write this concept logarithmically. Colin. You can even talk in a little microphone. Would you like to do that? Okay. Had a little scholar come up, right? He wrote this perfectly correct. The 3 became the little guy. He was the base. 3 squared is 9. Crisscross applesauce. Left, right, center. Somebody want to come write C logarithmically? Tyler. All right, we just had 2 more example problems finished up here. 5 squared equals 25. You really want to make sure that base is your little guy. Your exponent is on the right side, and your solution's in the center. And the same exact thing happened with 10 to the third power is 1,000. Okay, we have some special cases to jot down. These are special cases because zeros and ones are involved, honestly. Basically, anytime you have a logarithm, it doesn't matter what the base is. If you have a 1 appearing right here, the answer is going to be 0. And that's because any number to the 0 power equals 1. I think I have an example of that right here. We'll get to that in a second, though. The other special case is if you have a logarithm of a base, and that number matches this number here, like maybe they're both 5s or something, I don't know. They would kind of cancel out and become a 1, because any number to the first power would be that number right back at you. So once you write down those special cases at the top, we'll try these 2 special case examples at the bottom I've got here. Move them up a little bit. They're hiding. Okay, so let's look at this first example problem here. We've got log base 12 of x equals 0. When it's written logarithmically, it's just easier for me to think of it exponentially to try to figure out maybe what that missing x must be. So I'm going to write exponentially. 12 to the 0 power equals x. That's the true concept here. The little guy's the base, 12 is your base, 0 is the power, and x is the answer. And then you just think, what is 12 to the 0 power? 12 to the 0 power is 1. Any number to the 0 power is 1. And if you can't remember it, you could type it in. 12 to the 0 power, type in the calculator, will be a 1. All right, and then at the bottom, same deal. I'm going to write it exponentially to kind of think through it. This little 6 I'm underlining right now is my base. This x over here is going to be my power. And then this 6 over here is my answer. And if I'm thinking 6 to what power would be 6, it's the first power. 6 to the first power would be a 6. So x has to be a 1. I don't think I have another one under here, but let's look. Nope. All right, good to go on those two. All right, so what we're going to do in these next 2 or 3 slides is we're just going to have one of the guys be missing. Either the base or the exponent or the answer is going to be an unknown. It's going to be a variable like x. And we're going to try to figure out without using a calculator. If we have to use the calculator to help us figure some of them out, we can. Because sometimes we have to square root things and sometimes we have to do a little harder math skills. All right, so here's what the problem looks like logarithmically. Log base x of 20 equals 2. What would it look like exponentially? Lee? Yeah, x squared equals 20. My 2 came out a little weird, so I'm going to rewrite that so it looks nice. Now, this might be one where we're going to need the calculator, because I don't know about you guys, but I don't know how to take the square root of 20. I guess I could write it in an exact form. If I wanted a decimal, I would need the calculator. Let's just write it in exact form to practice our radical reducing skills. How would I reduce the radical square root 20? Remember doing this from before break? I think we did on the exam review. Square root 20 is radical 4 times radical 5, and radical 4 is a perfect square. So I think that this would be a perfectly fine answer. If you want the decimal equivalent, then just type in square root 20. If you're curious, I typed it in. It's 4.47. Not knowing if you want an exact radical form or decimal form. All right, ready? The original problem is log base 3 of x equals 4. So it looks like our middle guy, our center guy is missing this time. Let's put it in exponential form. What would it look like? Ava, haven't heard from you today. Good. 3 to the 4th power equals x. Let's see if we can do it without the calculator. We're trying our mental math skills today. 3 to the 4th is 3 times 3 times 3 times 3. You can do that in your head, right? What's 3 times 3? 9. What's 3 times 3? 9. So it'll be 81. Good to go on that one. This time looks like the base is missing. So we've got log base x of 12 equals negative 1/4. Oof, we got a fraction here. Let's see if we can figure this one out. How would I write it in exponential form? Alex, haven't heard from you today.
X negative 1.
Yeah. It has been a while since we've solved something like this, but we have solved something like this school year. You guys remember? Where's my scholars with the really good memory? What can we do to both sides to solve for x? Do you remember, Lauren? No? Tyler, you remember?
Reciprocal.
Yes, we're going to take both sides to the reciprocal power. So we're going to take both sides to the negative 4 over 1 power. So 12 to the negative 4th power. So if you want to use your calculator right now, that would be okay with me. You could always do the flip and make it positive method. If you did the flip and make it positive method, it'd be 1 over 12 to the 4th. So basically, it's going to be a little bitty decimal. So yeah, the decimal my calculator just gave me is in scientific notation. So if you don't want, what I'm seeing on my calculator is 4.82 times 10 to the negative 5th. If you don't want it in scientific notation, you'd have to do it by hand. You'd have to figure out what 12 to the 4th is. 20736. So this answer or this answer would probably be fine. I think that was a good one. another one very, very similar. It's the base that we're missing, so let's put ourselves in the exponential form. Carson.
To the third power equals 56.
And then what would we do on both sides to solve this?
Cube root each side.
Cube root each side. Yep. I was thinking of my perfect cubes, like 8's a perfect cube, 27's perfect cube. None of them are going to reduce down, so let's just figure out what the decimal is. In the calculator, cube root 36. 3.3. All right, so this is a little bit different. The way they're showing it to you, there is no equal sign, and there is nothing on this side. So what you're going to do is you're going to put the equal sign there yourself and put the variable there yourself, because truly that's what's missing. It's the guy on the right that is the missing guy. Now I have a little note here. Try to do them mentally. Use your calculator if needed. Honestly, I'll show you right now. There is a logarithm button in your calculator. I'm going to show it to you. It's right about here. You hit log. Uh-oh, mine doesn't having the new software. Let me pause my video real quick. Okay, we're gonna actually just do them all mentally and worry about the log button at a later date when I figure out why my calculator's not working like I thought it should. Your base is gonna be 4, your exponent's gonna be x, and then it's gonna be 64. So I guess what you could do is you could use your calculator right now to experiment. We know it's not 4 squared. Let's see if it's 4 cubed. It is. 4 cubed is 64. So that's how you could use your calculator to kind of figure it out that way. All right, I figured out what the problem was. I'll show you the button on the calculator now. Here's one of those cases that my brain wasn't awake yet. So you have to use the special log button in the math menu. So it's math, up, or math A. And that way you'll get your little button, which is a 4, and your bigger button, which is a 64. That was just the case of Mrs. Harp's brain wasn't turned on at 8:15 in the morning, but I found the button for you guys. Math, up for me. Maybe you need a different amount of ups depending on which model of calculator you're using. So that's kind of how you can cheat and use these in the calculator. There are some teachers that don't let you use a calculator at all on log quizzes because they don't want you using that special log button. So just be aware of that. All right, so I'm going to show you how to do this one with no calculator whatsoever. You're going to have your equals x over here. It will be 5 to the x equals 0.2. And you're probably like, well, I could experiment all day here. Or what we actually try to do is make the left-hand side match the right-hand side. So 0.2 as a fraction, if you hit 0.2 and you turn it into a fraction, it's 2/10 or 1/5. Now I'm going to try to make my left-hand side match how my right-hand side looks. Now this is a little bit weird. I know that this 5 right here is 5 to the first. And I know there's that song, Flip and Make It Positive. You can actually flip it reverse and make it negative. So I can flip this to the top, make it a -1, and then I have something that makes a little more sense. If 5 to the x power equals 5 to the negative first power, I knew that my x had to have been a -1. So I'm going to pop it back in just to prove that it works. This is me checking my work. So I can check, that's a 5. I can check in my calculator that 5 to the negative first power equals 0.2, and it all kind of works out. So you kind of make your left-hand side match your right-hand side to allow you to deduce what the exponent should be. All right, same deal. We're going to try this without the calculator button. We've got our x over here. So exponentially, it'd be 1/5 to the x power equals 125. I'm going to try to make my left-hand side match my right-hand side again. I know that 125 is 5 to the third. I recognized it as a perfect cube from, last month when we were doing our perfect cube talking. Now our 1/5, I just talked in the last slide that 1/5 is actually equivalent to 5 to the negative first. So here's what I technically have right now. This -1 and x, they can multiply together. So I've got kind of a mirror image on my hands. 5 to the negative 1x equals 5 to the third allows me to conclude that negative 1x equals 3. And I can just divide that negative 1 to the other side and get that x equals negative 3. Now, definitely I encourage checking the work. So let's check this. In case I messed up, it's early in the morning. My brain's not always on. So we have a 1/5 here. We have a 125 here. And we're going to see if it's a negative 3. So is 1/5 to the negative third power going to be 125? Yep, I just typed it in. 1/5 to the negative third power is 125. And last one on the slide. 36 to what power is 6? 36 to what power is 6? It's almost weird when you have to go from a big number to a small number. So the exponent's probably going to be some sort of fraction. I'm going to make my left-hand side match my right-hand side. 36 is 6 squared. And then this 6 is 6 to the first. So I kind of have matching here. 2x equals 1. 2x equals 1, and x is at 1/2. So what we figured out is 36 to the 1/2 power. I'm checking it right now. 36 to the 1/2 power is 6. It checks out. All right, hey, thanks for watching. Everybody's looking really tired. We have like one more concept to cover. And that is the common logarithm button and the natural logarithm button. So there are 2 buttons on your calculator I'm going to show you right now. First is this log button I accidentally hit earlier. Anytime you use that log button, the base is automatically a 10. So if you would type in like log 100, what you actually just typed in was log base 10 of 100. So the answer is going to be 2 because 10 squared is 100. You see it? So anytime you use this button as is, the base is going to be a 10. So I don't know how you want to jot that down, maybe like it is in the purple box. A common logarithm has a base of 10. Oftentimes in the textbook, that 10's invisible, and that's what's happening on the calculator. The 10's invisible. The 10 is just an automatically assumed number. And then there's also a natural logarithm button. This button right here, this button right here is called ln. That has a base of e. Anytime you hit that ln button, the automatic base right here is an e. So it's invisible oftentimes. Should have used a different color so it popped up. This base is an e right there. And this base is a 10 right there. They're just invisible. There's so many numbers that it can be invisible in math, it's hard to keep track. Square roots, 2's are invisible. Logarithms, 10's are invisible. Natural logarithms, e's are invisible. You think of other numbers that are invisible in math? 1's are always invisible. 0's are always invisible. So as they finish up writing, I'm going to recap the 3 buttons that you can kind of use in the logarithm chapter. You can use this button here if you want. Oops, I'm writing on my calculator instead of pushing buttons on my calculator. You can hit this button right here if you want to use base 10, this guy. You can hit this guy right here if you want your base to be e. And if you want your base to be anything else, like base 5 or base 2, you hit math, up, up. That guy. Okay, so you found all the buttons today. That's 3 buttons in one day. This is a big day. Everybody's really tired. It's the second day back from break. All right, well, thanks for watching this 24-minute video. It was kind of long for a Tuesday morning. You are going to have a worksheet. It's 4.4 day 1. Make sure you find the correct assignment when you're looking for it. My students, it's a worksheet posted in Polaris in the homework folder. Have a good one.